Alright, let's get this thing started. We'll be starting with my paper on behavioral changes over the Precambrian-Cambrian border, based on the findings of B. Weber, M. Steiner, and N.Y. Zhu. So the research in this paper is done in the Yangtze platform in China, in the Gaojiashan section, which is towards the north, the Yangtze Gorges, which is towards the east, and the Meishu-kun in the west. This is a picture of the stratigraphy in the areas. It shows the geographic time for each of the sections. For the purpose of this bit of research, the people here just explored the Gaojiashan section, way into the Precambrian, aka down by the base here, followed by the Yangtze Gorges in the center, and topped off with the Meishu-kun finds in the Cambrian area. So, for the first section, we're going to talk about the pre-Ediacaran area of the Yangtze platform in the Gaojiashan. The trace fossil you see towards the top there was most likely caused by metazoans who fed either by scratching the surface of the seafloor, the mat scratchers, or by scraping the area just underneath it, the undermat miners. The second one is Shangchiles, which are trace fossils that have been considered to be body fossils, but the authors of this paper don't agree. The great number of them in one area points to the idea, for these guys at least, that shows the feeding and propagation of an early opportunistic consumer. So that means that there were not only large but mobile metazoans during the Dangying. Alright, now we're going to move on to the Ediacaran period in the Yangtze Gorges area, and the trace fossils that they left behind. By this point in the history of life, there are distinct signs of movement, as seen in the trace fossils here, known as Palaeophycus. These signs of movements are actually much larger than the Shangchiles that were shown in the last slide. These fossils point to the feeding patterns of a deep-sea opportunistic consumer versus the shallower ones that were the metazoans, as they rely on the more vertical movement instead of the horizontal that the metazoans were using. Finally, we reach the Cambrian era as we transfer over to the Meishu-kun section of the Yangtze platform. Here we have plentiful fossils, both of trace and of body, in all different kinds of life forms. The pictures shown here are trace fossils of non-arthropods. The Didymoclus on the left were trace fossils that are actually found alongside arthropods that may show the development of the predator versus prey situation. The ones on the right are the Gregaria, or the vertical burrows, which have been unheard of up until this point, which means that the ability of burrowing in itself has developed to improved to accommodate the changing needs of the life forms. On the surface of the ocean floor is another behavior that has grown and developed, the mat scratchers. You can see that the look has changed from the picture of the metazoans in the Gaojiashan section. It's bigger, deeper, and acts more like a mollusk trail in that the surface itself was consumed for added nutrients and not just scraped over. The final specimen taken by the authors of the Cambrian groups are pre-trilobrite arthropods. Here we have an actual imprinted body fossil of one of them, and the traces around it include all kinds of digging in all kinds of directions. On top of that, there are also worm trails that were found alongside it. What this means is that the arthropods were digging to catch prey, who were then digging and building burrows in order to survive. It's the beginning of the true predator versus prey scenario. There were also arthropod fossils that were deposit feeders that relied more on surface feeding method that involved crawling and grazing rather than hunting. What this all means is that there's a lot of different types of arthropods doing a lot of different things in order to get food. Now that we've seen all the evidence as shown by the authors, we have to think, how does it all add up? Well, we already have large and relatively complex metazoans at the very beginnings of it all. These guys can be shown as the starting point of behavior changes for all other life to come afterwards, as more mobile lifestyles are developed. Better burrowing leads to the ability to get more food, which then most likely led to predatory lifestyles being developed. What we're left with are extremely diverse lifestyles from the simpler to the more complex. And so, as the variety of life increased, the behavior patterns began to grow and change more and more, developing as far as they could, as over the Precambrian into the Cambrian border.
Inferring the behavior of dinosaurs through fossils is often very speculative. Only very rare specimens have given us a glimpse of dinosaur behavior. Trace fossils have the ability to indirectly reveal behavior. Some very good trace fossils have shown dinosaur behavior such as crouching, sitting, and nest construction. The recognition of ground nests seemed to suggest that digging was an evolved behavior. A discovery in Montana was made of Cretaceous burrows containing one adult and two juvenile dinosaurs. They revealed that digging was utilized in den construction as a way of parental safeguarding. Recently, 3 trace fossils were discovered from the capping sandstone member of the Wahib Formation. The first trace fossil appears to be a Maniraptorian theropod dinosaur, displaying what appears to be digging behavior. The other 2 trace fossils with the dens of mammals. The assumption drawn from these trace fossils was that the Maniraptorian theropod used excavation techniques to prey upon mammals. The Wahib Formation is uniformly divided into lower, middle, upper, and caping sandstone members. The Ichno fossils are located west of Escalante, Utah, in the capping sandstone member, 4 meters below the contact of the Caparowitz Formation. The capping sandstone member is made up of braided steam channels filled with small overbank and eolin deposits. The Ichno fossils are located in an overbank deposit. Seismographic soft sediment deformation features are prevalent in the capping sandstone member, but are recognizable from biogenic structures through the application of diagnostic criteria. The 3 types of ichnofossils come from a single bedding surface at the bottom of a bedded sandstone. It cross-cuts the underlying bed of mudstone that varies in thickness from 20 to 70 centimeters. All 3 of the fossils are filled with sublithic sandstone, similar to the overlaying sandstone. The ichnofossils were not taken from the ground and were observed based on their natural exposure. The first trace fossil found is of the dinosaur. The overall size, geometry, and claw impressions record the digging behavior of the dinosaur. A track origin can also be found. Evidence shows repeated entry through a hole. This can be concluded from the linked multiple cone-shaped impressions and associated downward arching striations. The scale and morphology of the claw impressions found concluded that the trace maker was in fact a dinosaur. They also found downward arcing marks that indicate downward foot flexure to cup and rake the dirt out of the hole. The reserved type 1 claw trace has curvatures characteristic of a second pedal digit. This trace indicates that the lateral groove was reduced but present on the claw sheath. It was found that these 2 trace fossils were crayfish-like invertebrate and vertebrate burrows. They had multiple chambers, branching patterns, along with complex underground mazes. These are indicators of a complex social behavior and are similar to modern-day mammal burrows. The fossils indicate that there was a very large terminal chamber with many claw-marked burrow networks leading to the chamber. The trace fossils indicate that these animals were engaged in highly social behavior. These types of dwellings are not associated with solitary animals. These burrows function as a shelter, and predators can be thwarted by the length, diameter, and depth of the burrows.
Stegosaurus lived in the early Cretaceous of the Mesozoic era. They had elaborate cranial ornamentation, frills, and horns. A group of researchers found 6 well-preserved fossils in the Lujiatun beds of the Yixian Formation in China. This picture represents what those 6 juvenile Psittacosaurus may have looked like. As you can see, it shows them beginning to have a slightly complex cranial structure and horns. The origin and evolution of social behavior in derived ceratopsids is poorly understood, and so the question being asked is, how did they socially behave? This is the fossil site that the researchers found of the 6 Psittacosauruses. Note how they are well preserved. They partially overlap each other, but there is no mixing of elements between 2 adjacent skeletons. Based on X-ray diffraction, the scientists determined that the material was a combination of volcanic crystals and a high percentage of silica and clay. There was evidence of reworking, which supported that they died downhill. There were highly weathered volcanic rock fragments, a co-presence of volcanic rock fragments and sedimentary rock fragments, and volcanic mineral grains. This evidence allowed them to come to the conclusion that the dinosaurs died downhill of a volcano that was erupting at that moment, or died of the debris. Also, this shows that they died relatively quickly due to the absence of bioturbation. This image shows the material the scientists examined to determine the circumstances in which the Psittacosauruses died. The floating grains texture indicates that there was a rapid deposition, which supports the conclusion that they died fairly quickly due to the volcano. The researchers examined the femur length to determine the ages of the Psittacosauruses. They did this because femur length is known to scale with body mass in living archosaurs. Also, they used the body mass of the largest Psittacosaurus in a previous study in order to estimate the body masses of each Psittacosaurus in this study. They then calculated the body mass using developmental mass extrapolation. They were able to estimate the age range of the group. The results were that the age range was about 1.5 years, and they assumed that this would represent two different cultures. The researchers came to a conclusion that the fossil site represented a small herd of Psittacosauruses who died in one mass mortality event, meaning they were all together when they died, and that the herd consisted of more than one age class. They concluded that this showed post-nesting social behavior in basal ceratopsids, meaning that complex social behaviors emerged early in ceratopsian evolutionary history.
Research done by Timothy Myers and Anthony Fiorillo in their piece Evidence for Gregarious Behavior in Age Segregation and Sauropod Dinosaurs explains the strange behavior in the social life of the ancient creatures. As the title suggests, paleontologists believe that sauropods traveled in age-segregated herds and have found several sources of evidence. The team combined two types of evidence to seek an answer regarding this unique question. The ichnological evidence is made up of footprints and various trackways. The trackway accumulation provided further information and insight regarding speed and direction of travel and spatial organization of the herd. The research team placed emphasis on these trace fossils since the team specifically focused on herd composition and behavior. The paleontologists investigated sauropod herd tracks from all over the world to find if the herd was composed of a single age group. They used data from 13 sites from Portugal, China, the United Kingdom, South America, to the United States. The evidence they found from these trackways was somewhat conflicting. 5 of the sites contained only juvenile trackways, 4 contained solely adult tracks, and the remaining 4 were composed of both age classes. While this ichnological evidence is the strongest to answer the overall question, the conflicting mixed groups required additional resources in order to hold a strong position. To confidently assume the age group of these prints, 17 Baleosaurus fossils were found in the Wickawan Formation of northwestern China. These vertebrate fossils were consistently small and maintained unfused neurocentral sutures, suggesting a youthful age. In Germany and other sites, mixed age group herds were found, but the presence of other taxons left room for potential error. The Mother's Day Quarry is located in the Morrison Formation along the northwestern rim in the Bighorn Basin in south-central Montana. The site has incredibly low taxonomic diversity, with only one sauropod taxon and one theropod taxon present. This eliminates the possibility of any taxonomic bias or any post-mortem mixing with other sauropod material. All sauropod materials were found to be well preserved and, more importantly, strictly juvenile or subadult. For example, the vertebrae found had unfused neurocentral sutures. The lack of fusion of neurocentral sutures in these dorsal and caudal vertebrae suggests immature development. The Big Bend Alamosaurus site in the Upper Cretaceous Javelina Formation of West Texas is thought to be the remains of an ancient lake margin. It is an excellent site for the research and contains multiple juvenile dinosaurs used in study. Specifically, 3 femora were found together and labeled as juvenile due to their size. Their femora were 50% to 60% the size of an adult Alamosaurus sanjuanensis femur, and the neurocentral sutures are infused on each of the vertebrae. Adult fossils remained at distant locations of the site, but were always in isolated instances, allowing the researchers to assume the adults were solitary and the immature youth herded together. Whether it be Mother's Day Quarry or Big Bend, the skeletal evidence discovered is entirely juvenile and infers that parental care is minimal or non-existent within certain sauropod taxons. These monospecific cases are important because they determine the extent of variation in gregarious behavior within certain groups of dinosaurs and may allow delineation of evolutionary trends regarding herding. To further explore the case, the research team believes the next step should be developing taxonomic history for each site to further understand the site formation. If interpretations of age segregation based on the Mother's Day query and Big Ben evidence are correct, these sites confirm a unique aspect of sauropod behavior that has few other supporting examples in the fossil record. Because the size difference is so extreme depending on the maturity of the sauropod, it could be possible that there is an increased cost of survival with young sauropods, forcing the elderly to abandon their youth. It may hold implications for understanding parental care as well. If juveniles form their own groups, parental care must not have lasted far beyond the hatchling stage of development, if it exhibited at all. As you've seen, development has changed behavior in the ancient past. Complex behavior developed in the Precambrian to the Cambrian border regarding burrowing, prey, and mobility. Evidence exists in the rock record of dinosaurs using extrication techniques to prey upon smaller mammals, demonstrating dinosaurs' ability to hunt and gather. Complex social behaviors, such as herding, emerge in the ceratopic evolutionary history, and that herding may have even become more complex with age segregation and bias within groups.